You may be asked to construct a sequence given some specific conditions. So for example, in your notes, it says the second and fifth terms of a sequence are 3 and 24 respectively. Find explicit and recursive formulas for the sequence if it is arithmetic and then if it is geometric. So here's how I'm going to set it up. I want to give you a visual here. I'm just going to put blanks for my terms. So I don't know the first term. I know the second term is 3, third, fourth, the fifth term is 24. So if this is arithmetic, I have added the common difference 3 times. I've gone from 3 and I've added the common difference 3 times to get to the number 24. So that would mean if I'm solving this that D equals 7. I can confirm that. It's probably a good idea to confirm that. If I add 7, I get 10, and then 17, and then 24. So then I can figure out my first term, which is what I need to write my equations, by subtracting it. Nope, that would not be negative 7. That would be negative 4. Trying to talk and write too much at the same time. 3 minus 7 is negative 4. So if I write my recursive formula, that would be a sub n is equal to a sub n minus 1 plus 7. N is greater than or equal to 2. A sub 1 is equal to negative 4. Explicit would be a sub n is equal to my first term, negative 4 plus n minus 1 times my common difference of 7. We should always simplify. So 7n minus 11. And my personal opinion and suggestion to you is after you get that explicit formula, plug it in a couple of times to make sure that it works out. Like plug in 1. 7 times 1 is 7. 7 minus 11 is negative 4. Plug in 2, since they gave us the second term. 7 times 2 is 14. 14 minus 11 is 3. And I go ahead and plug in 5 just to make sure. 7 times 5 is 35. 35 minus 11 is 24. Okay, plug it back in just to confirm that you got those specifics right. Now, what if we have the same sequence, but it is geometric? So same setup. Second, third, fourth. Okay. But this time I'm not adding the common difference. I am multiplying by the common ratio 3 times. So 3 times the common ratio cubed, r times r times r cubed, gives me 24. So r cubed is equal to 8, because we divide both sides by 3. And then if we take the cubed root, the cubed root of 8 is 2. Our common ratio is 2. Check it. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 3 divided by 2 to go backwards would give us 3 halves as the first term. So our recursive formula, a sub n is equal to our common ratio, 2, times a sub n minus 1. N is greater than or equal to 2. A sub 1 is 3 halves. Explicit formula, a sub n is equal to the first term, 3 halves, times the common ratio, which is 2, to the n minus 1. And I'd just leave it like that. You can simplify it, but you really don't have to. So I'd just leave it like that. And again, it never hurts to plug in and check. Plug in 2. Okay, 2 minus 1 is 1, so 3 halves times 2 is 3. Plug in 5. 2 to the 4th is 16. And 3 halves times 16 is 3 times 8, which is 24. Okay. All right, let's do one more like this, just to make sure we've got it. The second and sixth terms of the sequence are negative 64 and negative 4, respectively. We're doing the same thing. Third, fourth, fifth. This time it's the sixth, though. So we are adding the common difference 4 times. We start at negative 64. We add our common difference 4 times, and we end up at negative 4. So if we add 64 to both sides, that gives us 60. So that means that 60 divided by 4 is 15. Our common difference is 15. So our recursive formula, you can check it if you want to by seeing if the terms work out, but I'm just going to go ahead and go on with my equation for the recursive form. I do need to find a sub 1 though, because my recursive formula always requires that I tell what the first term is. So if I'm going the other way, that would mean I started at negative 79. Negative 79 plus 15 is negative 64. So my explicit, which I needed the first term for this one too, a sub n is equal to the first term plus n minus 1 times d, which is 15. Always simplify. So 15n minus 94. There's no reason not to check it. Plug in 2, plug in 6. 15 times 2 minus 94. 15 times 6 minus 94. It gives me the second and sixth terms. If it's geometric, we start at negative 64. We multiply by the common ratio 4 times, so that's r to the 4th. We end up getting to negative 4. So if we divide both sides here by 64, it gives us a decimal. Let's put it in fraction form. That's 1/16. If we take the 4th root of both sides, the 4th root of 1 is 1. Any root of 1 is 1. The 4th root of 16 is 2. So that says that our common ratio is 1/2. So our recursive formula, a sub n is equal to the common ratio times a sub n minus 1. N is greater than or equal to 2. Our first term, if we're multiplying by 1/2, that means we started at negative 128. Our explicit formula, a sub n, is our first term, negative 128, times the common ratio, positive 1/2, to the n minus 1. And we could, of course, confirm that by plugging in 2 and 6. So negative 128 times, if we plug in 2, that's just times the 1/2. That's negative 64. If we plug in 6, that would be raising that to the 5th power, and that gives us negative 4.